Right, I'm going to keep on developing this idea here. We've got two brackets with an x in both of them, and I'm going to put let's put x plus 1 and x minus 1 and see what happens there. Let's just expand that. Well, that's x minus 1 plus 1 times x minus 1. That's x squared minus x, because that x multiplies there and multiplies here, plus x minus 1 equals, well, something quite magical happens here. That minus x there cancels out that plus x there. Look, we've got a plus x there, and a minus x there. They cancel out, they annihilate one another, because one's positive and one's negative. It's like giving me 50 quid and then taking me 50 quid away again. Or it's like walking 20 miles north and then walking 20 miles south. Well, anyway, you get the idea. These two guys cancel each other out. Equals x squared minus 1. Crucial identity. It's so important, I'm going to write, in fact, it's so important, I'm going to write it in a different colour. X plus 1, x minus 1 equals x squared minus 1 for any, this is how important it is, value of x. Okay? Super important. I'm going to verify that that works for a value of x. What value of x am I going to choose? Something really complicated? 194.6? Well, I could do, but no. I'm going to start with 0 because that's the simplest one. Let's work out the left hand side. Write it out again. X plus 1, x minus 1. X equals 0. What have we got? We've got 1 times minus 1, because the 0 plus 1 is 1, there it is, and 0 minus 1 is minus 1, equals minus 1. What's the right hand side? Well, it's x squared minus 1. I could go back to black now, I guess. At x equals 0, we've got 0, because 0 squared is 0, minus 1 equals minus 1. Ha! It checks out. In fact, I'm going to go back to black now. X plus 1, x minus 1 equals x squared minus 1 for any value of x. I'm going to generalise that in a little while, but for the moment we're just going to play with it. Let's try x equals 7. So what's the left hand side? Well, the left hand side, just substitute x equals 7 in there, and we've got 8, because that's 7 plus 1, times 6, equals x squared minus 1 is 49 minus 1, equals 40. Well, we knew that. 8 sixes are 48, but look, we've got that square number, take away 1 to give me 48. Let's try it with x equals 10. X plus 1, x minus 1 equals x squared minus 1. See what I'm doing here. I've got this nice little identity, x plus 1, x minus 1 equals x squared. Oops, what's happened? Oh, there it is. X minus 1. And I'm just writing it out again and again and again. And what I'm doing now, I'm playing with it. I'm seeing, does it work for x equals 10? Well, let's try. What's the left-hand side? Well, that's 11, because it's 10 plus 1, times 10 minus 1 is 9. And what's the right-hand side? Well, that's just 100, because it's 10 squared, minus 1. Oh, well, look, that's 99, because 11 9s are 99. And look, that's 99. Aha, it works. Well, that's nice. So it works for 10. What about fractions? Does it work for fractions? What happens if x equals 1 1/3? Just because I feel like. X plus 1, x minus 1 equals x squared minus 1. Well, let's verify it for x equals 1/3. What's this one? That's 2 1/3 times 1/3 equals 2 3s are 6, 7 over 3 times 1/3 equals 7 9ths. Now let's do this one. That's 1 1/3 times 1 1/3, because that's what we're substituting x in, minus 1. Well, it's minus 1 because of that. Equals 4/3 times 4/3 minus 1 equals 16/3 minus, try that again, equals 16 9ths, because 3 3s are 9, take away 1. Equals 16 9ths, take away 9 9ths, because 1 is 9 9ths, See how slowly I'm going? Yeah, sure, I could do it all in one step. Of course I could. It's what I do for a living. But it doesn't hurt to go through it stage by stage, piece by piece, number by number. 16 take away 9. Well, that's 7, isn't it? Ha! In fact, I'm going to change colours. I'm going to go up there and there and there. Same number, 7 9s and 7 9s. So it seems to be checking out. It seems to be checking out. Well, I think that's wonderful, so I'm going to stop there.